Hello everyone. In this lecture, we will study one of the dominant elements of both the translational and the rotational motion mechanical systems. So that is the friction, which is denoted by capital B here, and it is you can represent that by a damper or a dashpot. Okay, this figure, it represents the dashpot or the damper. It is called as the dashpot or the damper, and it represents that there is a friction. Now, whenever there is a motion, then there exists what? There exists friction. Okay. So here, this friction, it exists between a moving element and a fixed support, or between two moving surfaces. Okay. Now, the friction, it is non-linear in nature, and it can be divided into three types. That is viscous friction, static friction, and the Coulomb friction. The viscous friction, it is one of the dominant of all these three frictions here. And here, this viscous friction, it is assumed to be linear with the frictional constant B. And there exists a linear relationship with relative velocity between the two surfaces. Now here you can see this is a dashpot or a damper, which represents that there is some friction, that is there exists some friction. Now if you consider this mechanical system here, you are having a mass and you are having a dashpot which is connected in between the moving surface. This mass M is moving surface and this is the rigid body. Okay, so and you are applying a force F of t, there will be a displacement x of t here. Fine. Now the equation for this, it can be written as F friction is equal to F friction is equal to B, capital B. This is nothing but the frictional constant. That is equal to what? That is equal to F friction is equal to B into dx of t by dt. This dx of t by dt is nothing but the velocity. That is x of t is your displacement. The differentiation of the displacement will be the velocity. So along with dashpot, you will be always getting the velocity, that is the dx of t by dt. Now if you take the Laplace of this, it will be f of s is equal to b dx of t by dt. Its Laplace is s into x of s. Okay. Now one more example here is you are having two moving surfaces M1 and M2. In between these two, B is connected. Now here the friction element, okay, here it will store the potential energy. It means what? It will consume some force. So this friction element, it will consume some force, that is it will store the potential energy. Now here we are applying a force on mass M2. There will be a displacement x1. Then that force will be transferred on to this dashpot here. So it will consume some force, and the same amount of force it will not be applied to M1 here, because of which there will be a change in the displacement. Here it was x1, now it will be x2. So because of which we can write the force equation for friction as B into dx1 of t by dt minus dx2 of t by dt. And this in Laplace can be written as F friction is equal to B. For this we'll get it as s into x1 of s minus s into x2 of s. From these two terms we'll take s common and we'll get x1 of s minus x2 of s. Okay. So friction between the two moving points, it will cause what? It will cause a change in the displacement from one point to the other. So always you have to remember, whenever the friction is between the two moving points, then it will cause a change in the displacement. Now here we have seen that there are three types of friction. That is the viscous friction. Then you have one more was what? Friction, static friction, and the Coulomb friction. This is the figure for the Coulomb viscous friction here. Okay. So F friction is proportional to what? It is proportional to velocity. So always the frictional force will be proportional to the velocity. Or on x-axis we are taking the velocity, on y-axis we are taking the F friction, and this is the slope. Okay. So here this is the slope which you are getting it as B. Fine. So now next is the static friction. So this static friction, it exists when there is no motion. That is, the body is in still condition. That is, this static motion, sorry, static friction, it will prevent the start of the motion, and it vanishes as soon as the body starts to move. That is, it vanishes when motion begins, and it is given by this formula here. F friction is equal to plus or minus Fs when the velocity is 0. This x dot is nothing but the velocity. Fine. That is dx by dt. So this static friction, it exists when the velocity is 0. Next is the Coulomb friction. So this Coulomb friction, it will be having a constant magnitude with respect to change in the velocity. So here the velocity is positive. So the magnitude, it is constant here, but in this positive. So the value for the friction constant Fc, it will be constant. And here it will be constant with negative sign. Here it will be constant with positive sign. Okay. So the constant magnitude will it will be having a constant magnitude with respect to change in the velocity, and the sign of the direction, it will change according to the direction of the velocity. So Fc here is nothing but the Coulomb friction coefficient, and this F friction for the Coulomb friction is given by Fc into dx of t by dt divided by magnitude of dx of t by dt.